Well, hello Internet, and welcome to my Swift 5 video tutorial. In this one tutorial, you're going to learn pretty much everything you need to know about Swift 5 to start developing as macOS applications as well as iPhone applications. Like always, all the code is available in the description, and also a table of contents is available underneath the video so you can jump to exactly what you want to learn, and I have a lot to do, so let's get into it. Now, the first thing you're going to need to do is open up your App Store and type in Xcode, and you're going to see a guy like this, and you're going to come over here and click on this to either get or update Xcode. You're going to see here that you have to agree to the license agreement. Click on agree, and then everything will be installed for you. After that, you can click on the magnifying glass up here and type in Xcode to start up Xcode. And then a basic project would, just to show you exactly what's going on here, you can just click on single view app and next. Then you'd want to type in your project name as well as your own name, a unique identifier such as a website you own. You're going to have Swift, storyboard, and then uncheck all these boxes and click on next. Then you have to define where you want your project installed. Click on create. And this is Xcode, but we are going to be working with Playgrounds. But what we want to do first is verify that we have Swift installed. So what you're going to want to do is open up your terminal. Again, you click on the magnifying glass if you'd like and type in terminal. And you're going to type in or open up terminal. And then you're going to type this command to verify we have Swift 5 installed. So xc run swift-version and look for 5. And then after you have that all set up, jump back into Xcode and click on File and New and Playground. And I'm going to click on macOS and blank and then click on Next. And you're going to have to give your file a name. I'm just going to call mine Swift 5 Tut. Click on Create and then say where you want it to be installed and click on Create. Now if you want to change the size of your text, just click on Xcode and Preferences. You can see how tiny it is right here. What you're going to want to do is click on Fonts and Colors and then select everything, all of these guys right here, and then click on right here where we have a T for text. And then you can increase your font size to whatever you'd like it to be. Likewise, you could also click on Console, select everything, and click on T again and make that large as well. And here is the playground. Now, what you're basically going to show all of your output down here at the bottom of the screen, and all your code's going to go right here, and then also information about what you're doing over here in the code side is going to be displayed over here. Now, first things first, this is how we create a comment, just 2 slashes, and there you go. Now you have a comment, and also you're going to be able to make multi-line comments just by going like this, with a forward slash and a star and a forward slash. What we're going to need to do first, however, is to import the Cocoa module. And it's just going to provide all the classes and data structures you need to make Mac applications. Now let's talk about variables. Now if you'd like to create a variable in which a value can change for that variable, you're going to type in var. And then let's type in str is equal to and hello world, like that. There you are. You went and created a variable. And basically the rules for variable names is that the name needs to start with a letter, and then it can contain numbers as well as letters and underscores. Now you can use semicolons to end your statements, but you do not need to unless you're going to put 2 statements on one line. You're also going to be able to define constant variables by typing in let instead. So we could go str2 is equal to, and in essence what you just did was create a constant. Now it's very important to understand that these 2 variables are what we call global variables, meaning that all the code in this file will be able to access as well as change them. Well, not change this one because it is a constant. It's very easy to output information. You just type in print and then str will work. And then you can just click on this little guy over here to print down here your output. Now let's talk about data types. You're going to be able to define explicit data types, unlike what we saw here. What we did up here was we went and allowed the compiler to figure out what the data types were just by providing a string and then having the compiler say, hey, that's a string, and then turn it into a string. If you instead want to define a real data type, you could just come in here and say something like age and then int to define that this is an integer data type. If you want to know what the min and max values are, which I often like to know, and you want to go and embed code directly inside of your print statements, just put a backslash and then parentheses. I'm going to say, what is a 64-bit int maximum size, or this is the minimum size. Let's go and get the maximum size as well. In there like this, and go and get max, and then just change this to max, and run it, and you will see the minimum size as well as the maximum size. Now we're also going to be able to work with doubles, which are just values that have decimal places. So let's say we have something like pi2, and we want to define that as a float. That's exactly how you do that. You're also going to be able to go and define doubles, and I'll show you min and max for these guys as well. So this is how you create a double, and how you get the min and max values for these. Let's go and grab this guy right here. This is called string interpolation, whenever you take either a variable or code and embed it directly inside of a string that you're outputting. So let's say we want to get the maximum double that we can work with, and I'm going to show you the shortcomings of working with floating point data types here in a second. So to get the, well, this instance, we're going to get the min double. You just type in double and least, normal, magnitude, and let's go and get the maximum as well by putting in max double, and then you'll type in greatest, finite, magnitude. And if we run that, you're going to see the minimums as well as the maximums. However, it's very important to understand that floats are only accurate to 15 digits. So let's go and create a big float, and I gave it 16 decimal places, and I'm going to go and create another one after that. Just call this big float 2. Then if we would come in and try to output this calculation like that, and add these two values together and see what happens. Right like this. Well, make sure that you close off that with parentheses. And then if we run it, you're going to see that we have an inaccuracy right here. And as we increase past 15 digits of precision, you're going to get more inaccuracies. So just important to understand that floats are inaccurate after a certain number of decimal places. You're also going to have the ability to work with Boolean types. So let's go can vote and bool, and that is either going to have, or booleans are either going to have values of true or values of false. We'll get more into those as the tutorial continues. You're also going to be able to store characters. So I'm going to put my grade and say that this is a character, and I'll throw an A inside of there. And if you would like to cast from one type to another, let's go print. All that you're going to do is put whatever you want to cast to in front of whatever you're casting from. So let's say we want to go double to int. Just throw this inside of here. And you're going to type in int, which is what you want to cast to. Change the data type to. And let's also go in a different direction. Cast a int into a double. So just change this to int to double. Then you would just come in here and type in double, and then come over here and knock that off and run it. And there you can see the casting worked. Now there are other data types that you will use in special situations in which you want to specifically define how much space you want to set aside in memory. So we have all of these different versions of ints as well as large floating point units. And now I want to talk about some math functions. Now, of course, we're going to be able to come in here and perform additions. So let's say we want to go 5 plus 4 is equal to, and then perform the calculation directly inside of here. But also we're going to be able to perform other common calculations as well. So we're going to, of course, be able to subtract and multiply and also divide and use modulus, which is going to give us the remainder of a division. And also, the division is going to automatically switch from integer division to floating point division, depending upon if we're working with floats or not. And we can run this, and we can see our output exactly as we would expect. Now, there's shorthand ways to increment, decrement, and do all these other different things. So let's go create a new variable and call this num, make it an integer and 1. Now, you could either come in and go num is equal to num plus 1, or you could dramatically shorten this by just going in and having it be plus equal to, exactly like that, and that would increment the value of num for you. And of course, you could subtract the value of 1 or multiply the value or whatever, and you could also change this from 1 to 2 to 3 to 10 to whatever you would like. Now, if you'd like to generate a random value, which is often very useful, I'm just going to call this variable rand. It doesn't have to be rand. All you need to do is go int and random in, and then define your minimum and maximum. So let's say I want to generate a random value from 1 to 10. That's how you would do that. And then, of course, we can come and print out that value. Let's just change this to rand. And then to throw a variable inside of here, just go like that. And we can run it. And you're going to see it generated a random value of 2. And then when we ran it again, it gave us a value of 8. Now, there are a bunch of built-in math functions inside of Swift. And we can see here, we can run these. I'm sure you're well aware of what all of them are. See that we have the absolute value, different ways of either rounding up or rounding down, mins and maxes, power, square roots, logs. And then there's also going to be all of your trigonometry functions that are going to be available to you and a whole bunch more. But I just wanted to give you a brief overview of some of the common ones you're going to use all the time. And now I want to talk about conditionals. Now, your comparison operator is going to be all the ones that you're used to if you've used other programming languages. So greater than, less than, greater than or equal to, less than or equal to, or not equal to. And also, if you want to verify that two objects are pointing at the same reference, you would go and use triple equals. And also you could go not with two equals to check if they don't point at the same reference. So let's go and do a couple little examples here. So let's say we have age and it's an integer which is going to be equal to 8. Let's say that I want to determine what school a student should go to based off of age. So I'm going to go if age 2 is less than 5, and we're going to use curly brackets to define everything that's going to execute if this condition right here is true. So in this situation, I'm going to say go to preschool. Then I'm going to be able to say else if, and define another condition. So I'm going to say if age 2 is equal to 5. Well, in that situation, let's just go and copy this guy right here, paste that in there, go to, and I'll say kindergarten. And then we can continue making other conditions. So I'll say else if age 2 is greater than 5. And if you would like to make two comparisons, you would throw an and in there. If you would want this to be an either or, so if either condition came back as true, you would want to execute code, you would type in or like that. But we want to go and verify for both of these. So I'm going to say and age is less than or equal to 18. Well, I'm going to come in here and we can put multiple pieces of code, not just one. And I'm going to go and define the grade for our student, which is going to be equal to whatever age 2 is minus 5. And then we can go and output information. So I'll say go to and follow that up with grade, and then follow that up with the grade variable. And then also I could come in here and say else, and the default that's going to output on the screen if nothing else is true is go to college. All right, we got all that set. We can run it. And what did I do? Oh, I forgot to type in age 2 up here. So age 2, now it's fixed. Run it again, and now we'll get our output of go to grade 3. All right, so there you are. There's an example of if, else, and else if statements. Now I want to go and show you an actual example of the logical or statement, since you saw the and. So let's say I have income, and let's make this a double, equal to 12, and like that. So there's your income. And let's define that if a student would get a grant or not. So let's also go in here and define a GPA, grade point average. Make this a double, equal to 3.7. And then we're going to say, does the student get a grant or not? So get grant. And then we can come in and say if income is less than 15,000 or GPA is greater than or equal to 3.8, well, in that situation, we will define that the student gets the grant. And if we run it in this situation, you can see that yes, indeed, they do. So that's how an OR works. And also, we have our not logical operator. And what it does is if you give it a true, it gives you a false. If you give it a false, it gives you a true. Just like with many other programming languages. Throw this inside of there, and we'll say not true. This is going to give us a value of false in this situation. Good stuff. And now I want to talk about the ternary operator. Now basically the ternary operator is going to assign one of two values depending upon a condition. So let's say figure out if we can drive or not. Well, let's go and define this as a bool. It doesn't have to be a bool. It can be an int. It can be a double. It can be anything you'd like. So if the age, and let's go and create age, and int, and let's make this 15. If the age is greater than or equal to 16, and then if that statement is true, we are going to store the value of true in can drive. Otherwise, if it's false, we will store the value of false inside of it. And if we come down here and check it out, can drive and run it, you're going to see, whoops, I forgot to throw an equal sign inside of there. And you can see that it's false, that we cannot drive. All right, another way to match a limited number of values is to use a switch statement. So let's come in here and let's define a ingredient and have that ingredient be pasta. What I'd like to do now is to generate what we should cook based off of what we have available as ingredients. So I'm going to go in here and I'm going to say switch ingredient. So what this is saying is that we want to go and check for the value that is stored in ingredient. So case, we have tomatoes inside of our ingredient and pasta. Well, in that situation, we want to print out on the screen that the user should make spaghetti. Now, the way that switch statements work inside of Swift is even if this does come back as true, the next value underneath is also going to be checked. So I'm going to say beans, and in this situation, we will say burritos, and case, potatoes. We could say mashed potatoes. And then finally, if none of them are true, we're going to come down here to default, and we're just going to tell them to drink water. Whoops, and I accidentally threw in a colon there. Close that off, close that off. All right, good stuff. And if we run it, you're going to see the spaghetti comes back as true because tomatoes was the value assigned to ingredient. Now, you're also going to be able to use switch to match ranges, and we'll get more into ranges here pretty soon. So let's say that we have a test score. It's also common to have variable names use camel case, as you can see right here. That just means that every time there's a new word, we just uppercase it. So this is going to be int, and we're going to give it a value of 89. So if we want to match a range, we can go switch, and test score is what we're checking for. We could then say if the range is between 93 and 3 dots here and 100, well, in that situation, we will say you got an A. Otherwise, we can come in here and say if we are in the range of 85 to 92, well, in that situation, we're going to say you got a B. Again, case, you're in between 77 and 84. Then you got a C. And case, 69, 76, you got a D. And otherwise, the default action, if nothing else is true, is going to be you got an F. And if we run it, and make sure you have 3 dots inside of here, and if you run it, you're going to see we got a grade of B. All right, so there are numerous ways that we can perform different actions depending upon different conditions. And now I want to talk about all the ways we can loop. Now I'm going to define an array here to start off. And an array, of course, is just a data type that is going to allow you to store multiple values. So you can see those values right there. Let's change this to 3 just because it bugs me. Now you're going to be able to easily iterate through an array with a for loop. So we'll be able to say something like for item in array. You're going to use curly brackets again. And in this situation, we can just come in here and print the item on the screen, which is the individual array items. You can see down there we did it. You're also going to be able to iterate with ranges. So we can say for I in and go and create a range, and then come in here and print out all of those values. Well, let's just get rid of these altogether and just throw I there and run it, and you can see it printed those out. You're also going to be able to use a where clause. So let's come down here. So let's say I only wanted to print even values. I could say something like for I in, go and create a range from 1 to 10, where I modulus 2 is equal to 0. That means that if we do get the remainder of a division with 2 and it comes back as 0, that means it's even. So we want to print it out. So in that situation, we could go even and then throw in our value of I and run it. And you can see it prints only the even values. And you could also come in here and go not equal to print the odd values, as we did right there. Another thing we're going to be able to do is use something called stride. And that's going to allow us to iterate in kind of interesting ways. So let's say we go for I in stride, and we're going to say from, this is going to be where we want to start iterating from, through, and we want to iterate to the value of 2. And each time we cycle through our values, we want to decrement by the value of 2. We could then come in here and output all of those values. So you can see we can loop in multiple different interesting ways. And you can see that we did that right there. You're also going to be able to use this array that we created up here, just a series of values, and use for each to quickly cycle through those arrays just by going for each, and then follow that up with whatever you want to do, which in this situation is to print each value. And to do so, you're just going to use $ and 0 to get each of those values out of the array, run it, and you can see that it printed them out on the screen. All right, so there's multiple different ways of working with for, and then I'm going to cover some more in the examples that continue, but now I want to talk about while loops. All right, so while loop is going to work basically as a looping structure that is going to continue looping as long as a condition is true. So let's create an integer with a value of 1. One thing you have to always do with a while loop, for the most part, is have whatever you are going to be verifying or checking, have it outside of your while loop. So what I'm going to do is I'm going to say while I has a value that is less than 10, I want to continue cycling. I'm going to say if I modulus 2 is equal to 0. Well, you know from our previous example that if that condition is true, that indeed this is an even value. Well, I'm going to say that I do not want to print in that situation. So I'm going to increment the value of I, and then I'm going to type in continue. What continue is going to do is it is going to jump back up here and verify the value of I, and then continue cycling as long as the value continues to be less than 10. So that's what continue does. Otherwise, I'm going to show you how break works. So let's say that we want to break completely out of this loop if we ever get to the situation where I has a value of 7. We can just check for that equality, and if that equality exists, we will break out of our looping structure, meaning the while looping structure altogether. And in the meantime, we're going to print out all of the odd values. And then, of course, don't forget to increment the value of I, otherwise you will have an infinite loop. And if we run it, you're going to see that it prints out only the even values, but does not print 7. So there are while loops, and there will be more as the tutorial continues, but I also want to show you how repeat while works. Now, I showed you previously how to go and generate a random value. What we're going to do here is create a guessing game. So I'm going to say magic number, and this is going to be an integer, equal to int. I want to go and get a random value that is going to be within the range of 1 to 10, and then I'm going to have my computer come in here and guess the magic number. So int equal to, it's going to start at 0 and continue guessing until it gets it. So here's repeat while. One thing with repeat while is you can guarantee that it will cycle through the loop at least once. So what we're going to do is we're going to say print and output our guess, and then to do so, there's guess. Then we're going to increment the value of guess, exactly like this, like this. And then outside of our while loop, I'm going to say continue cycling as long as the magic number is not equal to the guess. And whenever that condition is no longer true, I'm going to be able to say, okay, I guessed the magic number, and in that situation, I can say magic number and go and get my magic number. Run it, and you can see in this situation the magic number was 2. If we run it again, you can see that the magic number was 5. All right, so good stuff. And for the final thing here with looping, I want to show you how to create an iterator. So an iterator is going to continue to pop out the next value each time that you call a function called next. I'm going to talk about functions next. So let's say we have variable I1 is going to be equal to, and I'm going to go and put a range inside of here. You could also have this be an array or any other data structure, but I want to make this into an iterator. Iterator, right like that. Now what I'm going to be able to do is cycle through it with any of our looping structures. So I'm going to say while let I is equal to I1. So as long as there is a value to get out of our data structure, I want to continue looping. And then I'll just print out the value of I as we continue cycling. And this is not that, it's I1. There we are. And run it. And you're going to see it prints out all those values. So there you go, numerous ways to loop. And now I want to talk about functions. Now, functions are going to allow us to reuse and better organize our code. So let's say that we would like to come in here and create a function that is going to go and add values together that are passed into our function. Well, what you're going to want to do, there's multiple different things you can do here. You could just type in x and colon and int, and then y colon int. And what we're doing here is we are defining that what our function does is it receives 2 integer parameters and returns an integer parameter as a solution. So then what we would simply do here is say return x plus y, right like that. Come out of here, print, say something like sum, and then we could call our function just by going get sum. However, you're going to have to type in these parameter labels in this situation. So you're going to have to type in x colon 5 and y colon 4. Close that off. Close off those parentheses. And if we run it, you're going to see that we do get our answer. If you do not want to use these parameter labels, just put an underscore and a space and an underscore and a space. And guess what? Now you can just type in 5 and 4 and get the same results. There you go. Now let's say that you do not want to return any value from your function. Like let's say you create a magical function that is called print2, and it does not receive any parameters and it does not return anything. Well, in that situation, you type in void, and in this situation, you would not have a return. But instead, you could do something magical, like I said, like print the word 2 out on the screen. Then you could come down here, and if you want to call a function, you just type in print2 like this, run it, and it prints the word 2. Now, something really interesting is we're going to be able to overload our function, which just means that we'll have multiple functions with the same name. And you can do this as long as the parameter data types and the return data types are different. So let's go and create getSum, and let's go and get rid, let's leave that right there. So we're going to have, I'm going to rename this getSum2 just so your code doesn't get messed up. So this is going to go and work with integers. We could also have it use exactly the same name, throw that in there, except change this to doubles, and change this to a double, and have the return type be a double. Now you're going to be able to have 2 functions with exactly the same name. Change this to 2, right like that. We do not need the parameter labels, 5 and 4. And we can run it, get the sum with integers, but also go in there and call a different function with our double values. And you can see that both work and we do not have any errors, which is very useful. One thing that is very important to understand, however, is that you can't change the values of parameters in ways that you can with other languages. So let's create a function, and let's call this change me underscore x colon int. All right, so this guy doesn't return anything, so we're going to type in void. And what we're going to try to do here is change the value of x. In most languages, that would not cause any problems at all. However, you can see here that you cannot assign a value to x. So that is a problem. By default, these parameters passed in here are let values. You can, however, work around that by coming in and you could say let x and int is equal to 10, for example, and then come in here and print those values if you would like, just to verify that they work. Well, let's have this be a lowercase x and x and x. And then we can come down here and call our function to run, pass in a value of 5, and see that it still prints out 10. All right? So just a weird little thing you have to be aware of. Another thing you'd be able to do is use in and out, which is going to allow you to change those parameter values. So let's just change this to change me2, and let's just change this to cnum. You're then going to come in here and go in, out. It's an in and out parameter is what it's called. It's not going to return anything. And then what we'll do is go cnum is equal to 10, and then output cnum like this and cnum like this. Change this to change me2, run it. And one thing to be aware of is you're going to have to put an ampersand in front of this to use in and out parameters. And you're going to have to use our variables, of course. So we'll say var, and you're actually going to get a reference to this variable in this situation. So we're going to say int equal to 5 in this situation, and change this to ampersand and cnum, run it. And now you can see yet another way to go and be able to change parameter values inside of functions. But you might say to yourself, boy, I'd like to return more than one value from a function. Well, you're in luck. You can do that also. So let's say we want to go and perform different multiplications on values and return both of them. So we're going to define that this gets a number, which is an integer, and it's going to return two values. Well, in that situation, you have to define what those two values are going to be and what the names are. So we're going to have 2 and 3 and int, and then what we're going to do is we'll say let 2, which is an int, is going to be equal to whatever the number passed in times 2 is, and then we're going to have 3 also defined in the function. So let and 3, and then we'll just multiply times 3 in this situation. And then we'll be able to return both of those values and get them by just saying return and then throwing inside of parentheses the values you want to return. You could then come down here and go let malts equal to 2 malts, pass inside of it number, and use the parameter label. You don't need to, but I did in this situation. And then you could print out both of those multiplications, products, whatever you want to say. And like this, and malts 2, and then also the second one, malts and 3. Run it. Whoops, what'd I do? Oops, 2 malt. There we are. And run it, and you can see both of those values have printed out. So you may say, well, it's great that you can return multiple values. What about receiving multiple values? Well, that is what we call Variadic parameters, and that just means that we'll be able to accept an unknown number of values. So let's go and create getSum3, throw an underscore, and then we will create a number array, which is going to be integers in this situation. And to create a Variadic parameter, just type in 3 dots, and then we're going to return a value. Then we can create a sum variable, int equal to 0, and then go and cycle through that guy. So in num array, add those values to our sum, and then after we're done with all of them, return sum. And then we'll be able to come in here and print get sum3 and throw in as many values as we like. It doesn't matter. And make sure that these names match up, and run it again. And also go and change this to I. Whoops, sorry about that. And run it again. And you can see the value of 10 comes back. And so we can continue covering everything. Let's also talk about recursion. Now, recursion is just the act of a function calling itself, which sounds complicated, but it's really not. So let's say we'd like to calculate a factorial. We're going to get a number inside of here. And I'm going to explain everything that goes on. It's going to return an integer. We're going to have a result, give it a value of 0. Now, anytime you use a recursive function, you're going to have a condition in which you are no longer going to call for your function to execute. So I'm going to say if number is equal to 1. In that situation, we're going to stop calling our function, but instead just return a value of 1. Else, we will call our function. And what we'll do is we'll say result is equal to num times, call our function again, but we're going to decrement the value of num each time, which eventually it will get to a value of 1. And after we do that, we can return our result. Now what we'll be able to do is do something like calculate our factorial. So let's say we want to find the fact of 4. Go, call our factorial function, pass in it a value of 4. And if we run it, you're going to see it comes back with 24. But exactly how does this work? Well, basically, this is how we're going to be looping. First time through, we're going to have a value of 4. We're going to decrement the value by 1, which gives us a value of 3. That 3 is then going to jump down here. There is your 3. Again, we're going to decrement the value down to 2, right, like we did here. It's going to bounce down here. 2 is going to come inside. Then you're going to get the factorial of 1. We're going to return a value of 1. We multiply 2 times 1. You're going to get a value of 2. That value of 2 is then going to jump up right here and replace this. You're going to go and get 3 times 2, which is going to give you a value of 6. That 6 is going to jump up here, replace this. You're going to multiply 4 times 6 and get your final result of 24. And that is how recursive functions work. Now we're also going to be able to take functions and assign them to variables, and then they will equally be able to be passed into functions and return from functions and so forth and so on. So let's go and create a function that is just going to multiply whatever is passed into it by 2 underscore number and integer, and it is going to return an integer. So we'll just say return whatever you pass inside of it multiplied times 2. Now what we'll be able to do here is let's go and create a variable called times 2 equal to whatever the function's name is, which is multiply by 2. We'll then be able to, of course, output this. So we'll say 4 times 2 is equal to, and refer to our variable name just as if it was a function. Pass 4 inside of it, close that off, and get our answer. See, just as we would expect. We're also going to be able to pass a function into another function. So in this situation, we're going to pass a function into a function but return nothing. So we're going to say run function, just call it f. You're going to have to put parentheses inside of there, and then say that it returns, and we're going to throw parentheses there. And then we can just pass the function inside of this function, and it will run it, but it will not return anything, as you can see right here. It'll probably make more sense whenever you see a function that returns something. So we could do something like function print 4, and it returns nothing. And all it does is prints 4 out on the screen. Well, now we can say run function and pass print 4 inside of it, and it's going to automatically print 4 for us. All right, so that's how to pass a function into a function that doesn't return anything. We could also pass a function that does return a value. So let's create a function here, and it's going to be called doMath and function. This one is going to receive this function that's passed inside of it is going to receive an integer, and then it is going to return an integer. Equally, it's also going to have a value that's passed inside of it, which is going to be an integer. Then what we're going to do is say print and result, and then we will run our function inside of it, which is going to be passed the value of x. Now what we can do is say doMath, call that function, pass times 2 inside of it, and a value of 4. And when we run it, we will throw the function inside of there, the times 2 function, also the value of 4, and then we'll multiply 4 times 2 and get a value of 8, which is what we got. To take it up another notch, we can also return a function. So this is a function that we're going to be calling function maker. So it's going to get a int value passed, and it is going to return int, which in turn returns an integer. Inside of here, yes, you can make functions inside of functions. This is going to be a function called add values. It gets a number 1, which is an integer, and it returns an integer. And what it does is it returns whatever num1 is plus whatever the value of value is. And then, now that we created this, we can return the function add values. Now what we can do is say let add4 be equal to function maker, pass in a value of 4, and we will be able to use this new function that we just created. So 4 plus 5 is equal to, and add 4, which gets a value of 5, and then we'll run it, and you can see we get our answer that we would be expecting. All right, so numerous ways of working with functions. Well, we talk about some more whenever we talk about closures. Now, a closure is a function that doesn't require a name or a function definition. So let's go create square. It's going to get an integer and return an integer. We can then say equal to, this is a variable, and num in, and then return num times num. Now what we'd be able to do is say print 5 squared, and then just call square and 5 like that, and there you get your answer. Now you're also going to be able to assign a closure to another variable. So let's go and create square copy equal to square, and let's just go and copy this right here, paste that underneath there, and then change this to square copy just to show you that it indeed still works, and it does. Another thing that's interesting is that you will be able to reference any values outside of the closure. So let's create a numbers array, just a series of values. So we're going to say 8, 9, 2, 4, 1, 0, 7. Now what I want to do is create a function that returns a bool, which is going to state if a value inside of this array is greater than the other ones. So let's go and go sorted nums equal to numbers sorted, and then we'll say by, and then inside of here we will get each of those individual values in that array and sort them based off of x being less than y, and change this to sorted nums so it makes sense. There we are. Now we'll be able to say for I in sorted nums, and then go and print all those individual values out. Run it, and you can see that it prints them all out in order. Okay, so good stuff. Another thing that's interesting is, let's say we wanted to go and perform different calculations on each value inside of an array. And I'm going to show you more about map later on, but we could also do something like go and square every item in an array. So we could say let squared nums be equal to numbers map, and then inside of here get our numbers string in, and go and multiply each of those values times themselves, and call this squared nums. And I'll show you another multiple examples of map here in a minute, and then we can come in and just print out those squared numbers. Run it. Whoops, forgot to put a parenthesis. Throw this right here. And now you can see that it went and converted all those into strings as well as squared those values. All right, it's just some neat little example. Just wanted to show you kind of the wild, crazy stuff you can do with Swift. And now I want to talk in more detail about ranges. All right, so as you saw before, ranges have a start as well as an ending value. So if we would say something like a ... c, that means that you want everything from A to C, including C. So let's go and say something like range 1 is equal to 1 ... and 3. Well, we get for I in R1 and go and print those values out on the screen. In some situations, however, you do not want to include the last value. So let's just go like this so I can show you an example. You'd also be able to go create another range and say you want everything up to but not including 3. Change the last dot to that less than sign. Change this to range 2 and run it. And in this situation, you see you get 1, 2, 3, and then you get 1, 2. You're also going to be able to combine ranges with for loops. So for I in 5 and 10, and then you can come in and print those values. And you would also be able to loop in reverse. So let's just go and run this just so you can see that that works, even though I showed it to you before. You'd also be able to say for I in, throw this around this, throw this around that, and then go reversed. Run it, like that, run it, and you can see those values are reversed. And one other thing you can do is you can check if a value is in a range. So let's say if we want to check if 5 in range, we could of course do that. And I'm going to show you multiple other different ways to check for values in ranges as well as arrays. And you're going to use contains in those situations as well. So we'll just say contains and 5, and it'll give us a value of true. All right, so I've been talking about arrays so much. Why don't we go and show you how they work in detail? Now, as I said before, arrays are going to contain multiple values, but one thing I don't know if I made specific is that they must have the same data type. So let's go and create an array, and we'll define that it is an integer array. This is how we go and create an empty array. You would be able to come in here and check if an array is empty by just going and putting in your array name and following that up with is empty. And if we run it, you can see that yes, indeed it is. You would be able to come in here and add values to your array by saying append and throwing 5 in there, for example. You could then add additional items. So you could just say something like array1 plus equal to and 7 and 9, for example. You would then be able to come in and get array values. So let's say you wanted to get the very first item inside of your array. You could say index 0 and array 1. Don't forget your parentheses, otherwise Swift will go crazy. And 0 like that. Run it. You can see that it comes back as 5 because that's the first one we put in. Get the next one by putting 1 inside of there. Running it. You see we got 7. You're also going to be able to change a value at a specific index. So let's say you wanted to go and put 4 as the very first item. Just do that. You would be able to insert at a specific index. So array1, insert, and you want to put 10, and you want to put it at the index of 3. You would also be able to come in and remove items. Say remove at 3, for example. Don't forget the colon. You could also come in and change multiple values. There are numerous ways of doing things inside of Swift, as you're going to see. So let's say 0 through 2, and you want that to be 1, 2, and 3 instead. You could get the length of your array by going array1 and count. You could fill an array with a repeating value. Let's go and create another array here. Let's call this array2 by calling array here and repeating. 0 is the value that is going to be repeated multiple times, and the multiple times is going to be 5. So that's an array full of 5 zeros. You could also combine arrays. So let's go create another array. Let's call this array3 equal to array1 plus array2. You could also iterate through an array, just as I showed you before in array3. Let's just go and see all of our results. Right like that, and run it. And you can see there's all the results that we have there. You could also go and get indexes as well as values. So let's go and change this to 4. And I'm going to put this index and value inside of here in array 3. And then you're going to go dot enumerated, right like that. And then we could print out those 2 values. So we're going to go index, closing parentheses, and value. Run it. And you can see not only the indexes, but also the values stored inside. We can, of course, create arrays that are made up of ranges. Let's go and create array 4 equal to array 1, 1, 2, 3, and 6. We can get a slice of an array. Let's go and grab this guy right here, paste that down inside of there. Just change this to array And let's get the first through the second part. So let's go and get rid of this. Change this to 4 and 1. 1, 2, 3. And there we are. And run it. And you can see there's our slice. You're going to be able to insert multiple values at a specific index. So let's say we have array 4, 1 dot dot, and up to 2 is going to be equal to, and we'll throw 9 and 8 inside of there. Grab this guy, throw that inside of there, and then just have this be array 4. Run it. There you are. You're going to be able to insert an array, but also keep the values. And how you do that is we would say array 4, and then we would just say 1 dot dot and 1 like this is equal to, throw 10 and 11 in there. And let's go and print out array 4 just so you can see the changes again. There you see. You're also going to be able to get index values. And how you do this is, let's say 11 index, go array 4, it's out of here, and call first index. And this is going to be able to get us our value of 11. But this is going to return something called an optional, which I'm going to cover in more detail here in a second. And to unwrap an optional, you have to put a exclamation mark inside of there. You can click in the table of contents to jump to the optional part, but just showing you how this works. And you have to put of 11, run it. See, that comes back as 2. See? Index 0, index 1, index 2. You can also come in here and check if an array contains a value. So let's say we wanted to find out if 11 was indeed inside of our array. You saw this before, but I'm going to show it to you again. You're going to use contains, and then 11 is what we're searching for. Throw another parentheses inside of there. We're also going to be able to get minimum and maximum values. So let's change this to min, and we'll just use array 4 and change this to min. So min, you're going to have to unwrap this from the optional again. And we're also going to get the max. And just to be really quick, what an optional is it is an object that has the option of containing no value or a nil value. And basically, I'll show you details as the tutorial continues. You can see all those values. As you can see, there's a bazillion ways of working with arrays. And if you want to sort arrays, that's how you do that. You could use reversed. Or let's show you an interesting way of sorting. You could say sort, and we want to get the first value inside of the array. That's how you do that. And then the next value inside of the array like that. And then sort them based off of whether one is greater than or equal to the other one. And this is array 4. You're also going to be able to create arrays of arrays or multi-dimensional arrays. So let's call this array 5 is equal to. And then you just put the arrays inside of them. So like this, separate all the individual pieces with commas, right like we do right there. And there you go, you just created a multi-dimensional array. We would then be able to get the individual pieces out of the array. So let's just change this to array. And let's say we wanted to get the second box. We basically want to get the 4 right here. So how we would do that is go array 5, get rid of all that stuff. Array 5, and then follow that up with 1, which is going to be the second box, and the first item in the second box. And you can see we got 4 just like we wanted. You're also going to be able to flatten an array of arrays. So let's create another array called array 6, call array 5, and you're going to call joined. So like this. Show you another way just to get odd values. So odds. We can call array 6 followed with split, and then we could say each of those individual items in the array, again $0, and we could check if it was a multiple of 2, parentheses, close curly brackets. So neat ways of doing all sorts of different things. You can see all those individual slices. We could also go and get even values in an interesting way. So we'll say array 7 is equal to array, and this is filter. So we'll say array 6, and we will filter, and 0 is multiple of 2. And then we can just come in here and print array 7. And boom, there's your even values. You can also do the opposite to get your odds. And we could also define that we want to create an array that is going to filter out items. Let's say we wanted to go and get array 6, and we want to filter out the values inside of it to only keep values that are greater than 5, for example. Could do that. We could also check if values satisfy a condition. So let's go print, let's say less than 12, and let's do array 6, and we will go all satisfy, and each of the array items, are they less than 12? That's what we're asking here. Run it. You can see that yes, indeed they are. And 2 more examples. Let's say we wanted to create a new array by multiplying a function on each value in the array. Let's go and create array 9 equal to array 6, and we'll use map again. And we'll just cycle through each item in the array and multiply it times 2. And then we could also sum all these values with reduce. I'm going to show you map and reduce again later on, just to give you some neat more examples. All right. And we will say array 9 and reduce it. We're going to start off with a value of 0 as we are reducing to a final value. You have to give it a starting value, which is 0. And then we'll just cycle through the array and add those values together until we get a final result. Pretty cool. And that's awesome. All right, so good stuff. There's a whole bunch of things you can do with arrays. And now I want to talk about dictionaries. Now, a dictionary is just an unordered list of key value pairs. And to create one, let's go create dictionary 1 is equal to, I'm going to create an empty dictionary here that is going to have integers and strings inside of it. And there you go, you just created a dictionary. Now you can go and check if a dictionary is empty or not, just by coming in and going dict1 is empty, right like that, and indeed it is. You're going to be able to create items just by going and saying dictionary 1 and 1 is going to be equal to Paul Smith. You can see this part is the key and this is the value stored inside of it. You're also going to be able to create dictionaries with a string key. So let's say we wanted to create customer and define your key and define your value, right like this. Then go 1, inside of your array, go 1, and let's say we want to have Sally Marks, and then define the next one, and Paul Marks. There you go. Just created a customer dictionary. You can go and get the size of your dictionary. Let's go and throw customer inside of here. And you're going to use count again. And you're going to be able to add items, of course. So customer, just define whatever the key is going to be. And let's have this be Doug Marks. You're also going to be able to change values very easily. So let's go copy this, throw that inside of there. Let's have this be Holmes instead. Gets changed into Doug Marks. And let's say you wanted to be able to get a value. You could say if let name is equal to customer 3. Well, then you could go and print. Let's just go steal this guy up here. Index 6, or index 3, I mean. And then throw the name inside of there. Run it. You can see it comes back with what you would expect. You would also be able to remove a key value pair just by going customer 3, giving it a value of nil. And of course, iterate through a dictionary, outputting keys and values. So key value in customer dictionary, like this, and go and get our key, key like that, as well as our value. And there we go. All right, so good stuff. Good rundown of dictionaries. Now I want to talk about strings. Now, strings are always going to contain text as well as escape characters, such as you see here, new lines, tabs, If you ever have double quotes, you want to put a double quote inside, you just backslash and double quote. Same thing with single quotes, and if you ever want to escape backslashes, just put 2 backslashes. Now, we have seen a lot about strings so far, but there's a lot more to see. All right, so let's just say we have a string, and we want to put a new line at the end of it, like that. We could also define multi-line strings. So we'll go string 4 is equal to, and you would just put 3 quotes like that, and then you could have multi-line strings like this, and then 3 more double quotes. I talked about string interpolation. That's whenever we can go and put a value inside of a string. So if you have your string and you want to put a variable inside of it, such as str4, that's how you do it, as we've seen in countless examples. You can combine strings. So let's go create string 5 is going to be equal to, and you can either use those strings above, or you can go and put new ones inside of here. So we'll go something like random string, and then plus, and then whatever you want. And here is another, right like this. You can check if strings are empty, of course. And we could do something like string empty, and then str5 and is empty. You're going to see the commands are used over and over again. Swift makes a lot of sense as a language. You could get the number of characters inside of it. So let's say that we wanted to go and get the size of it. We could come in and go string 5 and count again. And there you can see that. You can go and get individual characters. So let's say we wanted to get the first character. There's multiple ways of doing this, by the way. So let's just say we want first. You can come in and go string 5 and str5 start index, like that. Let's say you'd also want to go and get the 5th character. This is a little bit weird. What we need to do is define our index we're looking for, which is going to be index 5, like this. We could then go string 5 and index, and you need to define your starting index, and then after that, whoops, it's string 5 starting index. So string 5 starting index, and then the offset from that, which is going to be 5 in this situation if we want to go and get the 5th. So 5, there we are. And then we could come in here and print out that value. So we'll say 5th like this, and then go string 5, and then say that we want to use index 5. Index 5 like that. Run it. You can see we got D. We could also come in and check if a character would be inside of a string or not. So we could say something like s in string and check for the character of s. So string 5, and guess what we're using? We're using contains again, and just throw s inside of there. And you can also see here that we're able to put these double quotes inside of here without causing any type of error, which is also kind of cool. We could check if multiple values are stored inside. So let's say we wanted to do something interesting, like check for vowels inside of it. So we could do vowels, and then we just go string 5 contains, and then A, E, I, O, U. I guess you could throw Y in there as well sometimes. And just check all those individual values. There you can see. And what else can we do? So many things. You could come in and filter out different characters. So let's say we wanted to get rid of our vowels. We could come in and do something like Derek, like that, and then use filter, A-E-I-O-U, and contains, and then cycle through each of those individual items. You're going to see that we come back and get only the vowels inside of there. Let's go and say only vowels. There we are. Let's say you'd like to get the first 4 characters. Sure, you could do that. First 4. Come in here. Go string, string 5, prefix, and 4. And run it. And you can see, got the first 4. What else can we do? Well, we could split a string into an array. So let's go create an array equal to, go string 5, and split. And then we're going to define that we want to split everywhere there is a space. So there's our item equal to, and throw a space inside of there. And then we can use our for loop in array to go and print out each of those values of I. And there you can see are all the individual words printed out on the screen. You're also going to be able to remove characters at indexes. So let's say we wanted to remove the very first item. We could go remove and then just say at string 5 start index. Otherwise, you're going to have to, well, this is going to be parentheses, not curly brackets. Whoops, get rid of that. And then throw this right here. There we are. You're going to be able to insert a character at, let's say, the 0 index, insert. Let's say we want to throw a inside of there. Just say at, and then string 5, start index. And let's say we wanted to insert at index 15. Again, you're going to have to define your index by going in and determining the offset from the beginning. So string 5 dot index, and then it's going to be string 5 start index, and then define your offset, which is going to be 15 because that's what you said you wanted, or that's what I said I'm going to do. All right, and then insert, and what you're going to insert is going to be contents of, and you're going to insert this string, which is going to be the words is great, and where you want to insert them is at index 6, which we just defined. And we can go and print this, and this will just be string 5, just so you can see that that worked. See, there's is great. All right, couple other ones. Let's say you would like to get a string at a defined index. Again, you're going to have to go and define your index using offset. So we'll say index 7 equal to string and string 5 index, and specifically string 5 and start index, and then offset. And then offset by, in this situation, we're going to say 23, and then print, throw a string inside of here like that. And then we'll go string 5 and get a range. So index 6, index 7, and run it. And you can see we grabbed that block. And let's finally here, let's go and replace a string in a range. Let's go and go R3 is equal to index 6, 1, 2, 3, and index 7. And to replace it now, string 5, replace, and subrange, say R3, and what we want to replace it with, which is going to be this string that says is super. And we can go string 5, random string is super, here is another. All right. And is there anything else? Well, we could delete a string in a range. So we could go string 5, remove, subrange, and use that same range we had before. And I think that's just about it. All right, so there we go, and a whole bunch of things about strings. All right, so there you go, and now I want to talk about tuples. Now, tuples can contain multiple values of different data types, and if you want to define a tuple, you can just go and define what types you want it to have, just like this. And then you can go and assign values just by going like this, and then just make sure they're in the proper order. And there you go. You'd also be able to do this all on one line, and just define your data type, and then assign whatever you want the data to be that is contained in the tuple. Now you can also assign values from a tuple. So let's say we say s and age, and this is a string, and var I age, and this is an int. You could then say s age and I age is equal to t2, which is our tuple. And then we could go print s age and run this, and you'll see that age comes back, which is our string we stored. You can also get values from an index. So let's say we want to get whatever's in the very first index. We could do so just by going t2 and, whoops, make sure you put this in there, t2 dot and 0 index. And there you can see is our answer. You're also going to be able to change values. So T2, and we're going to change the very first one and change that to the string money. Just make sure the data types are the same. And you're also going to be able to assign labels to elements. So let's go and create another tuple. And we'll say this is a city, which is a string, and a state, which is also a string, equal to, and Ida, Ohio. Then you'd be able to come in and output something like this, and then just refer to the tuple with T3 and the label that you assign to it. And just make sure you close off this string over here. That's why I had an error. And you can see it printed out Ohio. And that's a quick rundown of tuples. Now let's talk about sets. Now sets are going to be unordered lists of unique elements. So let's say you wanted to create a set. I'm just going to call this nums is equal to, and you would call set, and then define that you want to have integers inside of it, and then parentheses, and there you went and created an empty set. You're going to be able to add values to it just by saying insert, and I'm going to say that I want to insert 1 inside of here. You can go and create a set from an array. So snums2, and this is a set, an integer set to be exact, and go and assign those values. Just remember they are unique. You can go and find out how many values you have inside of a set with count, just like you do with many other different data types or other different data structures. So just say snums2 dot count. You can check if a set is empty or not. Just go and copy this, paste this inside of here, change this to empty, and then type in is empty. Run both of those, and you can see those output down below. You're going to be able to remove values. So snums2 and remove, and we'll say that we want to remove the 3. You can check for a value. So let's say we wanted to check to see if 2 was inside of here or not. snums2, and again, we're going to use contains, just like we used previously. There we are. You're going to be able to insert values. Insert 2, this is snums, snums2 dot insert, throw a 5 inside of there. And of course, you can also iterate through a set in snums2, and then go and print out those values. And just make sure you use curly brackets, otherwise you will not get the results that you would expect. Paste it in there, run it, and you can see that output. All right, so rundown of sets. Now I said I was going to talk more about filters, so why don't I do that? So what I want to do now is I want to use a filter and go and take a list, which this is a list, so we'll call this nums2 is equal to, and I want to filter out everything that is not an even value. How do I do that? Well, I'm going to go even nums is equal to nums2 filter, curly brackets, and then inside of it, I'll go get num, which is int, and Boolean in, and then I will define my condition. So that is going to be that num modulus 2 is equal to 0. So that means I will be able to get those values for I in even nums print I. Run it, and you can see I only have even values. All right, so there's another example of how to use filter. And now I want to talk about enumerations, which are going to be used anytime you want to define types with a limited number of cases, which can somehow make your code more readable. So let's say we wanted to define emotion, and we're going to say that our emotion choices are going to be joy and anger and fear and disgust. Well, then we can come in and define a feeling and point at our custom emotion and say that the feeling being associated is joy. We can then change the value by going feeling is equal to dot anger. And then we can also check those values by just coming in here, and we can say angry, angry, and check if the feeling is equal to anger. So feeling equal to anger. Run it. You can see it comes back as true. All right, so just quick example of how we can use enumerations. Now I want to talk about optionals. Now an optional is a type that can either have or not have a value. And variables in general can't contain a value of nil. But in situations in which you can't guarantee you'll have a value, you can use optionals. And in that situation, the optional will have a value of nil up until a value is assigned. So let's create an optional. So I'm going to go optional name, say this is a string, question mark at the end of it to state that it's an optional, and then we can throw Derek inside of it. We could also create an optional with a null value. So we'll go age, integer is equal to nil. Now you can then come in and assign a value, and everything's good. However, it's important to understand that you're not going to be able to use an optional string or other data type as if it is a simple string. To actually get the string that it contains, you must first check if it has a value, and then if it does, unwrap it. Showed you how to unwrap before, but I'll show you again. So I'm going to say if oname is not equal to nil, and let's go check both, oage is not equal to nil. Well, in that situation, I can then say let uname string, and then unwrap the optional by just putting an exclamation mark at the end. Then once again, do the same thing for age. So change this to age. Again, this is going to be an integer equal to, and this is going to be age. And now in this situation, we can then come in and print those values. Hello, and then whatever. So we can throw this inside of here, uname, and let's also go and get our age. There we go, run it. And in this situation, you can see they are treated as strings because we unwrap them with the exclamation mark. Okay, quick example of using optionals. Now I want to talk about exception handling. Okay, so exception handling, of course, is just handling errors. And in this situation, what we're going to do is define a very specific error. And how you do that is go enum. And what we're going to be checking for here is a division error. So go and create that guy. And then I'm going to go case divide by 0. Then what I can do is create a function here. And inside of it, what I want to do is throw an error if I try to divide by 0. So this is just going to divide. It's going to receive a number, float, and another number, 2, also a float. And I'm going to define that it throws a float, call this num2. Then inside of here, I'm going to say guard num2 not equal to 0.0, else if it is a 0, well, I want to throw a division error, and then more specifically a divide by 0 division error. Otherwise, if we do not have an issue, I can just say simply return num1 divided by num2 and know that everything is going to work out fine. Then what I'm going to do is I'm going to wrap my code inside of a do block, any code that could potentially throw an error. And then I'm going to say divide, call our divide function, num1, and that's going to be 4, and num2 is going to be 0, so that will trigger an error. And then what we can do is call catch our division error, right like that, and divide by 0, and then we will print out a message that just simply says can't divide by 0, instead of crashing the whole entire program. And if we run it, you'll see that we just get an error message that we can't divide by 0. All right, so quick example of how we can use exception handling. Now I want to talk about structs. Now basically a struct is just an object type, and you've already been using them because inside of Swift, strings, ints, ranges, and a whole bunch of other different data types you've been working with are actually structs. So what we want to do here is create a struct that is going to simulate what it means to be a rectangle. So I'm going to say rectangle. And what are we going to have for a rectangle? Well, we're going to have a height, which I'm going to give a default value of 0.0. The equal sign inside of there. We're also going to have a width for all of our rectangles we create. All right, let's change this to length. And then on top of that, we're going to be able to include methods that we can perform with our custom data type here. And one of those is going to be calculating area. And this is going to return a double. And then inside of here, we can just say let area equal to height times length, and then return whatever the value of area is. Then to actually go and create a rectangle type, I can go my rect is equal to rectangle, define that my height is 10 and my length is going to be equal to 5. And then I can just come in and print area and then just say, well, let's say that I wanted to actually print out the values for height and length and all that also, just to show you how that works. You just go my rect and height, and it's going to give you that, and then we can throw multiplies times, and let's just go and copy this, paste that in there. This is going to be length, just to show you that there's no difference between printing out the values associated with parameters in here or calling functions, because we're going to call area right here, right like that, and run it, and you can see we got the answer we expected. All right, so simple example of how we can use structs. Now I want to go and actually do a really cool example of how classes and objects work. Okay, so basically classes are going to differ from structs in one main way, being that classes can actually inherit, meaning they can get all of the parameters, class parameters, and methods from other classes and automatically inherit them. So what I want to do here is go and create two warrior types. So we're going to simulate what it means to be a warrior, and then we are going to have these warriors fight to the death. So let's go and create a warrior class, and a class is just a blueprint for creating warrior objects in this situation. So what are some things, properties that every warrior is going to have? Well, a warrior is going to have a name. So we're going to define, okay, it's a string, and our default value is going to be warrior. What else is our warrior going to have? Well, if they're fighting to the death, we're going to have a health amount. So I'm going to have that be an integer, and I'm going to have it start off at 100. We're also going to have a attack amount because they're going to be attacking each other and their health is going to be dropping. So let's say a max attack is 10 by default. We could also say a block maximum and also an integer and 10. So it's potential that they could block the attacks if, whatever, if they weren't greater than 10. All right, what else are we going to do? Well, we're also going to have to initialize these values, which means every time a new warrior object is created, we want to assign values to these four properties. And the init function is going to be called every single time a new warrior is created. So it's going to have a name, and it is also going to have health, which is an integer, just as we defined it, a attack maximum amount, also an integer, and then a block max amount, block max, and also an integer. Okay, so now what we need to do is just assign all these values to this new warrior object we create. And since we don't know the object's name inside of the class, because the classes are created before the objects, we are going to use self to refer to the object's name. So this is how we go and assign these values. So I'm also going to have health, and health, this one's going to be the property passed inside of there, or the parameter passed inside of there. We're going to have attack max, attack max, and this is going to be whatever the attack max was that was passed inside, and then we're going to have block max and block max. And there we go. All right, so this is the function called to initialize and create our warrior objects. Anything else we want to do? Well, we're also going to want to calculate a random attack amount and a random block amount inside of here. So this is where we simulate a warrior attacking another warrior. So it is not going to be passed anything, but it is going to return an integer, and that integer is going to be a random value that is going to be from, well, we're going to have to say in, and it's going to go from 1, create a range, up to whatever the maximum attack amount is. So there it is. And then the block, the warrior is going to have to attack and block. Well, let's go and have the warrior block. And how we figure that out is by changing this to block max. Block max. There we are. There's our warrior. That's all we need to do to define a warrior data type. So pretty neat stuff. What else are we going to need to do? Well, we're going to have to go and simulate a battle between warriors. And to do that, I'm also going to create a new class that is going to loop through warriors attacking and blocking each other until they die. So let's go and create a battle class. And I'm going to have to start my fights. So I'm going to say start fight. Then inside of here, I'm going to define the warriors that are going to be passed inside to fight each other. And I just use their class type right inside of there, just like that. I'm going to do the same thing for the second warrior because they're going to fight each other. Paste that in there, change this to 2. And then what are we going to do? Well, basically what I want to do is I want to continue looping forever until one or the other warrior dies. So how are we going to define if a warrior dies? Well, I'm going to create another function that is going to have a warrior attack another and then determine if the warriors survive or not. I'm actually going to create a static function here. And the reason why it is static is because it does not require access to self. So that's a great reason to make a function static. It is a class function. That's what static means, which means that it should not have absolutely any need or requirement to actually access our objects. So I'm going to go static function, get attack result. It's going to be passed our warriors. So I'm just going to copy this guy right here, these parameters, paste those inside of there. However, to avoid confusion, I'm going to call this warrior A, and I'm going to call this warrior B. Come down inside of here. Now what I want to do is I want to go and get warrior A's attack amount by calling that warrior's attack. So I'm going to just call this warrior A attack amount, and that is going to be received. Whoops. And that's going to be an integer, and that's going to be received by going and getting warrior A and calling its attack function. I am then going to go and get warrior B's block amount. So I'll get this, paste that inside of there. So this is going to be warrior B, and I'm going to get the block amount. So there that is. And I can just call warrior B's block. And there we go. What else are we going to have to do here? Well, I'm going to have to calculate the damage to warrior B. So I'm going to go var damage to, and this is going to be warrior B. This is going to be an integer, and that's going to be retrieved by going and getting warrior A's attack amount, like this, pasting that inside of there, and subtracting warrior B's block amount. And there we are. Now after I do that, what I want to do is if the damage to warrior B is less than or equal to 0, I would just want to make sure that this damage to warrior B comes back as 0 so we don't get negatives, so that an attack doesn't add to the health of a warrior. So I'm going to use a ternary operator here. So I'm going to say damage to warrior B less than or equal to 0. Well, I'm going to give it a value of 0. Otherwise, it's going to be whatever the original damage to warrior B was. What else are we going to have to do? Well, I'm going to have to subtract any damage from warrior B. So I'm going to say warrior B health is going to be equal to whatever warrior B's health was before minus the damage to warrior B. Copy that, paste that inside of there. There we are. Now I'd probably like to print out some information on what the warriors are doing to each other. So I'm going to go and get whatever warrior A's name is. So I'll say warrior A name attacks, and I want to get warrior B's name. Whoops, make sure you get that parenthesis inside of there. Warrior B's name, and we'll say and deals, and I want to go and get my damage to warrior B, print that out, and throw damage at the end there. Close off that. There we go. Anything else I want to do? Well, let's go also. Let's just copy this and paste that inside of there. And let's say how much health basically warrior B has. So I'm going to say warrior B name, and we'll say is down to, and then we'll go and get the actual damage to, or the actual health amount. So we'll say like this, and warrior B health. And then after that, we can go and check if warrior B still has health or if warrior B dies. So we can say warrior B health less than or equal to 0. Well, in that situation, warrior B is dead. So we can say print and warrior B and name has died, and warrior A is victorious. So like this, paste that inside of there, change this to A, and is victorious. All right, so good stuff. Then we're going to return a message back up to start fight that is going to signal that we should no longer continue looping. And I'm just going to send back a descriptive phrase, which is going to be game over. Else, we do not have a death in our fight yet, so I'm going to say fight again, even though it's not going to matter. All right, so that is all we are going to do for that guy right there. Except I forgot to say that I was returning a string from this. So come up here, do that. There that goes, and then that error message will go away. All right, so how are we going to fight? Well, basically, I want to continue looping for forever until I tell it to stop. So we're going to use while true there. And then I'm going to say if and battle, how we're going to be able to call this function down here. Let's get rid of that. Well, let's go and get rid of this here. The only way we're going to be able to call this, since it is static, is we're going to refer to the class name. Remember, I said it's a class function. So I'm going to say battle dot get attack result. And what I'm going to pass inside of it is warrior 1. This guy right here, warrior 1. And then I'm also going to pass inside of it warrior 2. Right like that. And I'm going to say if this returns a value of game over, like I put down there, well, in that situation, I know that the battle's over, and I can go and print game over myself. And otherwise, I'm going to copy this guy right here and go and check the next one, because we're going to cycle through the warriors until one or the other is dead. Or actually, let's just end this, throw a break inside of here, and then copy it like that. And that's going to be the only way we jump out of our loop. And then we'll paste this inside of there, and then I'll just change this to warrior 2 and change this to warrior 1. There we go. And I have a little error here. Let's go and change that to a lowercase w and that to a lowercase, whoops, we'll do that. That to a lowercase w. There we are. Don't see any other errors. All right, and how we verify that we got some good code here is that we are actually going to be able to write very understandable code that is going to make it easy for our warriors to fight. So I'm going to create a warrior that is going to be Thor, and I'm going to say name is Thor, and I'm going to say that, what else are we doing inside of our warriors? Name, health, attack amount, block, max. So let's go and say that Thor has a health of 80 and a attack amount of 26 and a block amount of 10. We're then also going to create Loki. However, because Loki is not as strong as Thor, we're going to have to change some things. So I'm going to say Loki and Loki. And let's say that Loki has a maximum health of only 50, a maximum attack of 20, and a block amount of 10. Well, then what we're going to do is to go and have them fighting against each other. I just have to create a battle situation. So create a new battle object. No parameters are passed inside of it. And then to start our fight and simulate the whole battle, I can just say start fight and then throw Thor and Loki inside of there and see who wins. I think you can take a wild guess and figure it out. And if we run it, you're going to see the results of our attack right there on the screen. And you can see also at the very end, Loki has died and Thor is victorious. Now you can see also that Thor's health only ever goes down to 46. So what we would like to do is go and actually empower Loki with some magical powers. How can we do that? Well, we're going to do that through inheritance. So we basically want Loki to have some magical powers. This magical power in this situation is going to be the ability to teleport. And how we're going to do that is to go and inherit from the warrior class, but we're going to add a little bit more in regards to block to make Loki just a little bit more powerful. So I'm going to come down here and I'm going to define I'd like Loki to have the ability to teleport. Now, protocols are like interfaces in other languages, and basically the way they work is when a class adopts a protocol, it agrees to define any behavior that is defined inside of our protocol. So I'm going to say that I want a protocol that is going to say that anyone that signs up for our teleport protocol, that they must implement a function called teleport. And how you do that is you just say function, define the name of the function that is required, and then any return types or parameters. And that is all that you do inside of here. Now I'm going to go and inherit every function and property from our warrior class. And well, why don't I first off here define exactly what happens. So we're going to have the ability to teleport. So can teleport. And how we inherit from a protocol is just put its name inside of there like this. And then we define the function that is required. So function, and since it can teleport, this function in this situation is going to return a string. And what that string is going to do is it is just going to say return teleports away like that. We are also going to have another class that inherits from teleports, and it's going to be called can't teleport. And inside of here, instead, we're going to say fails to teleport. There we are. And now we will get to creating our brand new warrior that is going to inherit from the warrior class. So it is going to be called a magic warrior, and to inherit from the warrior class and get all those wonderful properties and methods, we just put a colon and the warrior. Inside of here, it is going to mainly have one additional property, and that is going to be teleport chance. And the bigger this value, the more than likely that the user, the magic warrior, is going to be able to successfully teleport. I'm then going to add the protocol functionality that we had up here, which is can teleport, which is going to print out a message that say teleports away. And to add that protocol functionality, I just need to say var teleport type equal to can teleport, and that's it. And then I will, if I want to create a new initialization function, I'm actually going to copy the initializer inside of warrior. But I'm going to have some of my initialization actually take place inside of the superclass of warrior. So I'm going to allow the warrior initialization function to take control and actually initialize some stuff. I am, however, going to add in here some additional functionality, and that's going to be teleport chance. So I'm also going to underscore teleport chance is going to be the additional piece of data passed into my magic warriors. I don't need any of these things because they're going to be initialized inside of the superclass, and how you call the superclass's initialization function is go super init, and then inside of here just pass over name, health, attack max, and block max, right like this. And then I will go and have teleport chance and assign it right here. Teleport chance is going to be equal to whatever the teleport chance was that was passed inside of this initialization function whenever we created a magic warrior. And then I want to just override the block function that's in warrior. I already showed it to you. I don't need to show it to you again. And how we override a function is we just say override, and the function's name you want to override. It doesn't receive any parameters. It returns an integer. Everything's the same there, except what we're going to do is we're going to say that sometimes our magic warriors are going to be able to teleport. So what I want to do here first is generate a random value from 1 to 100, and this is going to be my random dodge amount, and go and call random and in, and this is going to be from 1 to 100. Now what I can do is decide if the teleport is going to work based off of the value of teleport chance. So I'm going to say if my random dodge is less than self teleport chance, well, in that situation, I can print a message that says that my warrior was able to dodge, print, and I'm going to say self name, and then I'm going to call my teleport function, teleport type, teleport function, to print out that custom message. And I have that saved inside of here, right? Oh, teleport type, just make sure that's a capital T. And then after that, let's go and return a block amount that is huge, just to make sure that we can block anything pretty much, because we teleported. And then otherwise, I want to return the value that would have been originally calculated in the block class in the warrior function that we created, or the warrior class we created. How we do that is just super and block. There we went and added a ton of functionality to the magic warrior and Loki. And let's see if it's enough to actually make Loki survive. So we're going to have Loki here, warrior. We're just going to simply change this to magic warrior. And the really cool thing is Loki is still considered a warrior even though he's a magic warrior. And then, because up inside of our battle class, up inside of here, see, we're referring to Loki as if he's a warrior, because he still is. And that's an example of what we call polymorphism. And that just means if a class inherits from another class, we are still going to be able to refer to it as the superclass version. So even though it's a magic warrior, it also has everything that's in warrior, so we'll still be able to call it a warrior even though it's a more specialized magic warrior. So we can come down inside of here. We defined it as a magic warrior. And let's say that Loki has a 50% chance of dodging attacks. Everything else is exactly the same. And let's see how Loki does with his new abilities. And you can see Loki still died. But you can see that Loki still has the ability to teleport away, which was kind of cool. And he put up a little bit more of a fight because Thor was down to 25 health. Let's come in here and run it again to see if it's possible to get Loki to win this fight. And Thor has died and Loki is victorious. So there we are, fighting for the side of evil inside of this wonderful tutorial series. All right, so there's a quick rundown of a whole bunch of different things we can do with object-oriented programming inside of Swift. And now I want to talk about extensions. All right, so extensions are going to add functionality to existing classes, enumerated types, structs, protocols. But it's important to understand that you cannot use them to override existing functions. So what I want to do here in this example is I want to extend the capabilities of a simple double type so that it can work with distances. So what I'm going to do is say extension double, and then inside of it I'm going to define all of these different distance types, and our basic double is going to be a meter. And then we're going to define how that meter will change based off of converting from meters to kilometers, for example. So what we can do is we can say return self, which is going to be meter, times 1,000 in this situation. And then we can continue making all of these conversions to all these other different distance types based off of what we know about them. So here is our basic meter. In this situation, we would just return the value itself stored inside. Let's throw in a curly bracket here. And again, we could go and convert to centimeters, which means that we would multiply times 100. And we can convert to millimeters. In that situation, we would divide by 1,000. So just change this to division. And then we could also convert to feet. So let's change this, and we could convert to any type we would like, actually. So let's take self and then divide it by 3.28084. Okay, so now what this is going to allow us to do is to automatically convert from any of these types to any of these other types. So let's define what is 1 inch. It's equal to 24.4, and then we would put dot and millimeters to define that data type. Then what we would be able to do is we could say print 1 inch is, throw in 1 inch, and then automatically convert this into meters. And if we run it, you will see that that does work, and it's a great big giant long number. Likewise, we would be able to willy-nilly sort of combine these units. So let's say we wanted to define a marathon, and we wanted to say that it is 42 kilometers plus 195 meters. We could then say, let's go and copy this, paste that inside of there, and just say marathon is, and throw marathon inside of here, and it would automatically convert it to meters, as you see it did right there. Now what we want to do is do a little bit more of an expanded example. What I want to do here is go and allow us to define that we want to be able to sum both integers, doubles, as well as strings inside of one function using generics. So what we want to do here is we want to define a protocol, and it's basically going to define that any type that conforms to it is basically going to be able to be summed as long as they have the addition operator. So we'll say protocol and summable. Then inside of here, we will say static function plus, and then x self and y self, and it will return a self. Now what we can do is define that ints, doubles, as well as strings are going to conform to summable, and we do that with an extension. So extension int summable, and then we can do this for our two other different data types that we want to be able to sum inside of one function. So we'll just say double and then also string, and they will automatically just work with that addition operator. Because basically a generic is just a placeholder type in which the data type will basically be assigned later based off of what type of data type we're working with. So like I said, I want to make a function that's going to add both ints, doubles, as well as strings. So to do so, I'm going to call this sum, and then I'm going to place a t inside of here. And this is what is called a generic parameter. And basically what we're going to do here is we're going to state as long as the data type is an int, double, or string, as well as the parameters and return types are also of that specific same type, we are going to be able to add those values. So we will bind them with summable, and then to go x, t is going to represent that data type, y, and then t again. And just remember, we are also going to be returning a t data type, which is just a placeholder for what will be integers, doubles, and strings. Then what we can do is just say add those together and make it work, and it will. So we can come down here now and say print 5 plus 4 is equal to, and call our sum function, and then pass in a 5 and a 4 or an integer. And then we can also add doubles as well as strings. So we could say 5.4 and 4.5, and then also we could add in strings inside of here, and we'll just place different quotes around these. And there you go, and there you are. If we save that and run it, you can see that we're now able to add both integers as well as doubles and also string data types. All right. So there you go, guys, and that is a pretty complete coverage of the Swift 5 language. And what I'm going to do in tutorials that follow this is show you how to make iPhone applications. So like always, please leave your questions and comments down below. Otherwise, till next time.